Okay, so I didn't do this before I started videotaping, so it might be a little bit slower than the last one. So, first I made your hexagon right there, and it tells you that you have a radius, which is 7. So, the easiest thing is to draw it first. Hexagon has 6 sides, and then you always know the radius is somehow coming out of a vertex, or else if it's coming out of an edge, it would be the apothem. So, and that's what we're looking for, the apothem. So, you look at this, and then, whoa, here. Okay, so we're looking at this, and then we know there's 6 sides, and before we can find the apothem, we have to find the central angle. So, if we were to divide this off right here, finding the measure of this triangle would be a central angle. To find the measure of this angle right here, we will have, we know that this entire thing is going to be, hold on, (360) divided by n, which is 360 divided by the number of sides. So then we go to 360 divided by 6, which will give you 60 degrees, I believe. I'm doing that in my, no, that's not, is it? Okay, 300 divided by, okay, so we take 160 off, and I think it's 60, honestly. If it's not, I'm sorry. Do that on a calculator, check my math. You know what, I can do it on a calculator. It's 60. Okay. So back to this. We now know that this central angle right here is 60 degrees. So, but that's not going to help us right there because both of these lines that I made for the central angle attach to a vertex. So neither of these are an apothem because an apothem would be attaching to an edge, which is like in the middle of the vertexes. So let's make, wait, no, I'm still on that. Okay. Let's make an apothem right here. Now looking at this, and we know that since it's regular and everything, we pretty much know that this is straight, and this is going to lead us to have 90-degree angles around this apothem, which we'll need that later. But, so we're looking at this, and right now, we know 60 is this entire angle I marked with that little red line right here. If we're just going to take one of these triangles out, because now we know this green is the apothem, because it attaches to the edge. So to find out the apothem, we're going to go even deeper into this half of the triangle right here. And so this 60 is for the entire triangle right here. So if we just do half of that, it's now going to be 30 for just that half. Find a new color. There's a random dot there, sorry. 30. Probably can't see that. Okay. So half of that's going to be 30. If we redraw the triangle out here. Ah, dang it. Out here. We know that this is our apothem, so the green is what we're looking to find out right there. And then we know it's a right angle. And so with right angles, you always know you can use Pythagorean theorem, tangent, cosine, and sine. And then we also know that that is 30 degrees up there. Let me move that out. 30 degrees is this up here. 90 degrees. So if we know there's 180 degrees in a triangle, we obviously know that this down here is 60, and this is a 30, 60, 90 triangle. Okay, so if this is 7 right here, we're back up at the hexagon. If this is 7 right here, and these are two equal right triangles, because you know this 60 was divided into 30 each, these would both be 30, 60, 90, using all that triangle congruency we learned before. This radius right here, which is the side of this triangle, would also be the same as this triangle. So this is the hypotenuse for both of these right triangles, making it equal. So this would be equal on both of the triangles. And so we can put that down here. Now that we know all this information for this triangle right here, and we know we're trying to find out the green right there, we're going to use something. Okay, so let's say we're going to use, what do I want to use? Okay, we'll start using this 60 degrees right here. We're going to do the hypotenuse and, the hypotenuse and the opposite. So opposite and hypotenuse would be sine. So we've got the sine, what's it doing? The sine of, why is it doing this? Oh, am I on a button? Oh. Come on, bro, just do this. Okay. So the sine of 60 equals, and then so we're coming opposite over hypotenuse. So x over 7. And then I'm going to see if this computer calculator, wait here, did you see that? That's the equation I'm using. That's not focused. That's annoying, okay. So I'm going to see if this has sine on it. No, of course it doesn't, because it's just stupid. Let's look up an online calculator. Okay, so, what am I Googling? Oh. Oh, sorry. Well, this looks wonderful. Okay. This is really long. It shouldn't really take this long, but there's a lot of steps to it. Okay, so sine of 60. Is it not letting me do? Oh, okay. Is there an do I just press enter? Okay. So if you remember back from sine, you're going to take the first 4 numbers from behind the decimal. So 0.8660. 8660 equals x over 7. Alright. And then if we put this decimal over 1 and cross multiply, we're going to get x equals 7 times 0.8660. So I'm going to do that. 7 times 0.8660 equals 6.062. So x equals 6.062, not 3, 2. Alright. And so our x was our opposite. So we know that this, yours thing I believe said round to the nearest tenth. So that would be 6.1. Not 2. So we put 6.1 there. And since we know the green was our apothem, we're done. And that's the answer to your apothem thing. I have your other shape right here. I'm going to go ahead and send this to you first. And if you don't understand how to do it for this particular thing, I'll try to explain it real fast. Okay, so it gives you a diameter right here. I would, because I work better with radiuses, okay, I'd cut that in half and I'd show it as like a 9. And then I'd make your central angle, which is meeting with another vertex. You can't skip a vertex and just go over here. Your central angle is like radius connected with the next vertex right there. So you'd have like a triangle right there, okay? And then you do 360 divided by 8 because this is an octagon. And your equation is 360 divided by the number of sides. You're going to get a degree number. I don't know what 360 divided by 8 is off the top of my head. I'm not going to try to figure that out, but that's what this entire central angle is. If you put the apothem there, which splits it in half, you're going to have, like, I'm not going to, no. Okay, so that splits the degree you just got in half. And you have a right triangle. I'm not going to be able to do that. You have a little right triangle there then, okay? And you can bring it all out and put all the information you know. You do tangent, sine, cosine, whatever works. Fill in the information. You'd know that the hypotenuse of the right triangle you just made is the radius, which would be 9. And then your apothem would be your other side, your opposite. And it should be 90 degrees on either side of the apothem. And I'll do that one for you if you're still confused. But I tried to make a color-coded whatever this is. Alright, I'm going to send this to you now.